Hello and good afternoon, everybody. My name is Dury Long, and I'm an assistant professor in the Communication Studies Department at Northwestern University. And on behalf of Northwestern Center for Human-Computer Interaction and Design, I would like to welcome you to today's Thought Leader Dialogue on AI education. Artificial intelligence is becoming increasingly integrated across our technology ecosystem, but public understanding of AI is limited. AI education initiatives are needed to aid people in making informed decisions about their personal technology use, AI-related policy decisions, and the role AI should play in their schools and workplaces. In addition, widespread AI literacy has the potential to equip the public with skills needed to collaborate and create with rapidly changing AI technologies. We are lucky enough to have three fabulous speakers here today who are going to share their research on AI education through initiatives such as incorporating AI in K-12 education, designing novel and creative AI learning experiences, and engaging adults in learning and decision-making about AI in their communities. Our speakers today are Dr. Cynthia Brazil from MIT, Dr. Christina Gardner-McCune from the University of Florida, and Dr. Ken Holstein from Carnegie Mellon University. Today, we will hear from each speaker, and then I will moderate a discussion following the talks. Just a few notes before we get started. Today's event will be recorded. If anyone in the audience has questions during the talks, please post them in the Q&A throughout the talks. I will incorporate attendee questions in the panel discussion following all three of the presentations. The chat will only be used to share sources like introducing the conversation and speakers, so please do not post your questions there. I'm not even sure you're able to, so we will be following the Q&A. So without further ado, I would like to introduce our first speaker, Dr. Cynthia Brazil. Dr. Brazil is a professor of media arts and sciences at MIT, where she founded and directs the Personal Robots Group at the Media Lab. She's a fellow of the AAAI and is an international award-winning innovator, designer, and entrepreneur. At MIT, Brazil is the Dean for Digital Learning and the director of the MIT-wide Initiative on Responsible AI for Social Empowerment and Education, a research and outreach effort that advances access and inclusivity in AI education to people of all ages and backgrounds. She co-founded the consumer social robotics company, Jibo Incorporated, where she served as chief scientist and chief experience officer. Brazil is a pioneer of social robotics and human-robot interaction. Her robot balances technical innovation in AI, UX design, and understanding the psychology of engagement to design personified AI technologies that promote human flourishing and personal growth. Her seminal book, Designing Sociable Robots, is recognized as a landmark in launching the field of social robotics and human-robot interaction. Her recent work focuses on the theme of living with AI and understanding the long-term impact of social robots that can build relationships and provide personalized support as helpful companions in daily life. And with that, I will hand it off to you. Thank you so much.
Great. Thank you so much for that introduction. So I am really delighted to be able to join you today. I have kind of two quick objectives in this 10-minute intro. I'll try to speak quickly because I probably have too many slides. But the first goal is just to introduce to you a little bit more about RAISE. And RAISE is a MIT-wide initiative here. It's actually between the Media Lab, Open Learning, and the Schwarzman College of Computing. And the broad scope is really thinking about kind of the intersection of AI, education, and learning. So whether that is AI that is designed to help people of all ages learn, or help people of all ages learn about AI, all of that kind of fits under the umbrella. And we've really focused more on K-12 as well as workforce in terms of that mandate. So everything I'll be presenting today fits under this larger MIT-wide initiative. And then what I'd like to do is really focus on a particular program. The title of the talk is AI Literacy at Global Scale. That program is called Day of AI, and just to give you a little bit of an intro and some thoughts about how we can try to bring AI education to a large global audience. So just for some philosophy or approaches to how we at RAISE approach kind of all of our materials. We have very short format materials, which I'll highlight again in the Day of AI, to curriculum that are like multi-year curriculum all around AI literacy. So whenever we design these curriculums, we're MIT, we love constructionist learning. So, all of our curriculum really kind of combines and threads these multiple themes of often kind of multidisciplinary thinking and making, Of course, computational thinking. You'll probably hear again and again about these 5 big ideas of AI. And so this is really kind of a curricular basis for a lot of the work that we do, where the one in the center is of particular near and dear to my heart, which is the social impact. So how do you think about the responsible ethical use of these kinds of technologies? But we also like to put students in the driver's seat where they think as designers. So in design thinking, tools such as ethical design matrices, design justice frameworks. So they actually practice these design methods as they think about AI in projects that they may design themselves. We also develop a lot of cool tools to, again, enable kids of all ages to actually make things with AI. Again, at MIT, we love this paradigm of learning through making. We extend that to this idea of computational action, which is how can you empower students to make things that can have a meaningful impact in their community. So really kind of the very kind of outward facing view and thought process of how you make solutions that you really hope will benefit people like you. So you're going to kind of get a little sampling of some of these tools today, but certainly, embedding AI libraries and tools in block-based coding environments to make these kinds of hands-on activities more accessible is definitely along the kind of themes that we do quite a lot of. So the main thing I really want to introduce today is our work on a program called Day of AI. It is both a research program and it's a big outreach program. It is loosely inspired by the Hour of Code. So it's meant to be a short format experience that is kind of very accessible to all teachers. You don't have to be a STEM teacher or computer science teacher. And it's really more about bringing awareness of how AI is changing kind of what digital literacy and digital citizenship is today. So it is of broad relevance, and we try to demystify certain areas and applications of particular interest to students. So we launched the first Day of AI last year in May. The second one is coming up on May 18th. And so again, it's really focusing on in-classroom learning. And part of that is to say you don't truly reach all students until you can actually get into the classroom. Otherwise, students kind of self-select into after-school programs. So one of our big goals here was really to get into the classroom. Again, kind of our philosophy of responsible use and design and so forth is embedded in this multidisciplinary curriculum. And part of that is our hope of introducing teachers to a way of bringing a topic like AI. It's such a glue subject matter that cuts across so many aspects of society and disciplines that we want to use that as a way to show teachers implicitly through this curriculum how they can teach across disciplines and so forth in an engaging way for their students. Everything's free to use. We have professional training, both synchronous online as well as asynchronous videos that, again, completely free to use. And our goal is to really help design this in a way that is really engaging, that teachers will learn something from it, as well as students will find it very relevant, not only to what they use today in their everyday lives, but chances are no matter what they choose to do as a career in the future, AI very well may be very relevant to them. So the big kind of, I guess, overarching objectives is just to communicate AI is for everyone. It's not just, again, for computer science or STEM students. And we really want to empower students with the knowledge of skills of how to responsibly use AI in their daily lives. It should be designed responsibly, as I mentioned. And of course, kids are our future, whether they're going to be the designers and makers of the underlying tools and technologies or using them to, add value through their own domain expertise. We just want them to start thinking about AI in these terms and appreciate, the opportunities, but also the challenges that they present. So our overall curriculum, again, it's meant to be like a day's worth of content. Each lesson fits within an hour. So teachers are welcome to do as much or as little as they want. They kind of can offer it whenever they want. But we start with kind of this broad orienting, what is AI? Then teachers can choose a grade band relevant thematic unit. And so there's some examples I'll show you what those might be, like ChatGPT or creative AI, with generative AI. So they can choose an area, and inherent in that thematic unit, we try to demystify the technology. We try to let kids kind of think and make stuff with it. And then we want to engage in some critical thinking and discussion around that. So it's all kind of in that thematic unit. And then the end is this careers in AI, where we really have tried to make a point of highlighting diverse professionals and diverse industries, et cetera, et cetera. So again, students can relate to it and see it's really, quite broadly used in all kinds of ways. So last year we launched with 4 grade bands, so upper elementary, middle school, high school non-computer science, AP computer science, and then a more AP computer science track. And this year we basically added additional modules. Part of our goal is to try to be very timely and relevant. So we literally just released a curriculum on ChatGPT like a week ago. It's already the most popular downloaded curriculum. We're starting to work with other organizations like HCI+Design. So we added a K-12 unit. So we're starting to, work with the broader community to bring in quality materials. OSTP just released an AI Bill of Rights. So we decided let's do a Blueprint Bill of Rights for kids and have them discuss it. So again, more of a much more civics oriented model. There's no technology involved in that. Game AI and more stuff around data science. Our AP computer science data activism is actually around analyzing college admissions data, because of course the Supreme Court's going to be talking about affirmative action. And so we want kids to be able to be thoughtful and think about that dialogue as well. So again, we just really try to choose topics and technologies that are super relevant to them. This is just to say that we take the professional development side really seriously, because obviously it's not going to get any traction if you don't. We have found through experience, most teachers just want to do the asynchronous. We provide a lot of materials and video, but some actually really do want asynchronous online training that our collaborator i2 Learning provides. And this circle chart just shows, to our actually delight and surprise with their very first year, it was pretty even in terms of the interest that teachers had across all grade bands. We thought maybe high school would be the most popular, but again, this was actually pretty interesting for us to see. Again, we really believe in teacher agency. So we make it very clear to teachers that they can adapt, modify this curriculum. Again, it's designed to be multidisciplinary. Active learning as a way for hopefully teachers can bring this style of learning into their classrooms. Again, teachers can really choose how much or how little to do. So it really fits within their classroom experience. They choose when to offer it. So the Day of AI is actually a day of global sharing. So we make these materials available. We invite teachers to do whenever you'd like to. And then the Day of AI is a day of just global celebration. So on the right here is just when we launched the program last year, we thought we would only focus on the United States. We've just organically had so much interest from around the world. So over 3,000 teachers from 90 countries registered. They self-report teaching 500,000 students. Of course, we don't know how many actually brought the Day of AI to their students, but it just gave us a sense of just the global interest of this topic, which we were not expecting at all. So we did do a study. So again, we're doing research. I'm just going to fly through this because I don't want to take too much time. But anyway, questions about how effective our professional development is, questions around how teachers felt students were engaged in the material, and how did they adapt and change the modules to suit their classroom? Because again, these teachers are from all over the world and they're taught different kinds of subjects. So this other chart shows you the teachers who actually did respond to our survey. So 108 teachers from 20 countries. They self-reported teaching 7,000 students. So I think that's probably a believable number, at least from our sample pool. And these charts here on the right are just to show you overall, positive ratings on what we've done around the teacher professional development and classroom engagement, and some stats here on the teachers themselves. Many of them were more experienced, 10 years plus of years teaching. Majority of them actually were STEM teachers, but we had a range of teachers as well. So again, it was a good initial kind of sampling for us to get a sense of what's happening with this curriculum out in the world. Again, just as we did a survey around, how prepared did you feel you were, how adaptable was curriculum, positive, on the right track, I would say. They thought the student engagement was great. So again, just to say, seems like we're on the right track. Of course, there's always more you can do and improve, but it seems overall positive. So where are we going? Okay, so again, this is all free to use, and we're constantly expanding the curriculum, and we're starting to now reach out and collaborate with other organizations who want to add their content with us. Because if we can reach thousands of teachers around the world, a lot of people would love to have that opportunity, right? There's a lot of people around the world who are developing AI literacy curriculum. So we want to be able to make that possible for the growing community. It's all CC by SA. Again, a lot of attention we're trying to study in our own research, specifically how teachers adapt and extend our curriculum. And we actually have participation agreements for organizations that are big enough who can really take our materials and localize them to regionally relevant examples and applications. We admittedly have a very US focused curriculum because that's where we're from. So trying to partner and collaborate with other organizations who can bring it, one case we're having conversations with India where they've mandated K-12 AI literacy, or the Philippines and so forth. So really working with them so they can take these materials and really make them that much more relevant to teachers and students. And starting to now explore, how do we train trainers, because we can't train all the teachers ourselves. We want to be able to train trainers and allow them to train. So again, we're thinking about the scalability of that, but then also how do we really empower teachers, because they're the key to making this work for themselves and their students. So I'm going to pause there. Just, of course, exciting, the amount of interest. I think it's just exciting for all of us. And just to acknowledge a lot more to do and understand, but it seems like teachers are very, very interested. So I'll pause there.
Thank you so much for that presentation. This is really exciting work. As a reminder to the audience, please share any questions you have in the Q&A, and we will draw from them during the panel discussion after the talks are completed. Our next speaker today is Dr. Christina Gardner-McCune. Dr. Gardner-McCune is an associate professor in the Computing and Information Science and Engineering Department at the University of Florida, where she is the director of the Engaging Learning Lab. Dr. Gardner-McCune's research focuses on the integration of computing across the middle and high school curriculum. Through her research, she designs interest in disciplinary-based curriculum and after-school and summer camp programs to engage middle and high school students in science and computing. She uses these learning environments to broaden participation in computing and for computing education research. Dr. Gardner-McCune is the co-chair for the AI for K-12 initiative, which is a joint working group to develop national guidelines for teaching K-12 students about artificial intelligence. And Dr. Gardner-McCune was also recently awarded the 2022 AAAI Educator of the Year Award. And with that, I will hand it off to you. I think you're muted.
All right. Yeah, that's like the thing right now. Thank you, Dury. I will say that that award for AAAI Educator of the Year went to our AI for K-12 steering committee. So I shared that with my colleagues who helped develop the AI for K-12 guidelines. So do want to share credit there. So I want to talk to you a little bit about the work that we've been doing with the AI for K-12 initiative. And when we think about AI literacies, we're thinking and how do we support students getting AI literacy? We're thinking about what kind of infrastructure needs to be put in place at, from a standards level, from a state and district infrastructure level. So I'll give you a little bit about AI for K12.org. We just finished developing our 5th grade grand progression chart here. So we have completed our work on developing national guidelines for teaching artificial intelligence in K-12. We've modeled this after the CSTA standards for computing education, and we've developed 4 grade band progressions, 2 on the elementary school level, middle and high school, and they really define what students should know and be able to do with AI. We've been developing a curated AI resource directory for K-12 teachers, and really our first 2 goals with our grant, we were funded by the National Science Foundation to do this work, was to do the first two goals here. And along the way, as we started doing this work, a community of K-12 AI educators, researchers, and resource developers really started to form and blossom. So we try to help to continue to foster this community through different activities at EAAI, which is the educational advancement of artificial intelligence, research community, as well as doing talks with SIGSI, which is the Special Institute with Computer Science Education, as well as with ISTE and CSTA, so teacher-facing organizations. So we really try to make sure that we're helping to bring this community together. Our work was funded by the National Science Foundation, as I mentioned, and it's a collaboration between AAAI and CSTA, so a national or international AI research organization, and Computer Science Teachers Association. So really trying to look at how do we bring research into teaching practice. Here's a little bit of a picture of our first year of working on the guidelines. And you can see that the guidelines were really created by a group of teachers. And we found expertise in computer science, experts that were teaching computer science in K-12 across the grade bands and had been helping on national standards and state standards, and really bringing their expertise to bear to look at how do we bring AI to K-12 students. So this is one of a picture of our teachers that we worked with really closely, and also our advisory board members. And we organized the guidelines around the 5 big ideas in AI. And we really think about this as kind of a fundamental part of like, how do we define what are important skills and knowledge that students should have? And we organized around the 5 big ideas in AI. So the first one is around perception, how computers see the world. And the second, and that, we really feel like that's the way a lot of students are actually engaged in AI, right? Is, you know, using their smartphones to unlock them, or using TikTok or Instagram to, you know, do facial filters and things like that. So this is one of the first ways that they end up interacting when touching AI. And so we wanted to make sure that they understood, you know, how computers are using data from the world. The second is representation and reasoning. So understanding that, you know, what's happening in the background. Well, computers are building representations and reasoning about them. And the third is learning. So computers can learn from data, and think about machine learning. That's essentially that big idea. The fourth is around natural interaction. So understanding that agents are interacting naturally with the world. And there's all this knowledge they have to understand about us as humans and the world and how it works to be able to reason and interact with us naturally. So things like ChatGPT go very naturally here, Siri, Alexa, all the different devices and technologies that they're interacting with. And then the center is societal impacts. We really want to make sure that students understand that AI can impact the world in both positive and negative ways, and give them the skills that they need to be able to make ethical and responsible decisions for their personal lives as well as their professional lives. So as I mentioned, we've created grain band progression charts around these 5 big ideas. All 5 of them are now available, and each one describes each big idea. So this is big idea 1, really tries to codify along a number of sub-concepts. What kind of things do we want students to know about? So we have these orange boxes. These orange boxes really kind of highlight what's the key takeaways that we want students to have from these from each one of the big ideas. And so we'll kind of look at one a little bit closer. So this is from big idea 1. The sub-concept is on processing and understanding the difference between sensing versus perception. And so we have learning objectives. You know, we want students to be able to use a software tool such as speech transcription to demonstrate machine perception and how it goes beyond mere sensing. And then enduring understanding is, you know, perception is the extraction of meaning from sensory signal. It's not just, you know, so being able to, we often use in some of the curriculum that we've been developing for another project, you know, this picture of a deer walking into a grocery store. And we ask, does that door actually know, does it have the technology to know that they should be letting in this deer or not letting in this deer, right? And so they realize, oh, it's just sensing. It doesn't perceive that's not a person, and they probably should not open that door for that deer. So really helping them kind of understand that. And then we often have some unpacks that really help teachers. And really, this is more for teachers and curriculum developers to kind of think about what are the things that we want students to know. And so we'll do some unpack to explain those concepts. And we really feel like we're not creating standards. That's the job of states and organizations like CSTA or ISTE. We really feel like we're providing guidance for teachers and educators and curriculum developers and professional developers, so they can figure out, you know, if I want to teach about AI, what is out there, what should I be teaching, and how should I be teaching, and what's grade appropriate. And so that's what we're providing. And we know this is a living document. And so even though I say they're all complete, it means like the set is now out. We know that we're going to have to do iteration. And my colleague Dave Turetsky at Carnegie Mellon has already been saying, since ChatGPT came out, we got to work on big idea 4 again. And I'm like, shh, we just finished. Give me a second, right? So we already know this is a living document. And because AI is ever evolving, we're going to be evolving these as well. And so as we think about how do we support AI literacies, we think that we need to make sure that we make AI transparent to students so that they don't think that AI is just magic, or they just don't even recognize when they're interacting with AI. So understanding, how does AI work? So being able to look under the hood of, open the black box or look under the hood to really understand how AI is working. So having some transparent AI demos that will allow them to do that, helping students, and we believe this will help students build mental models of how AI is working, because if they can understand, oh, well, the reason why ChatGPT can answer questions about recipes is it probably has a bunch of data it's been trained on about recipes. And those recipes kind of begin to help build its knowledge about, what ingredients go together and what steps are most likely steps, so it can generate new recipes for us. So getting them to even understand these building blocks and having a system level understanding of how AI works, we think will be really, really important for them to ask intelligent questions about AI. We want them to be able to experiment with AI agents to investigate their behavior. So we have a demo called Speech Demo, where, usually now if you talk into your phone, it'll usually translate, what you say, and it only give you one option. Sometimes if you keep talking, you may notice, if you're paying attention, it may change a previous word because now that you've given it more context, it understands more of what you're trying to say and realize, oh, I probably didn't translate that right. But we have a speech demo that my colleague created that allows them to see the top, I think it's like 4 or 5 possible candidates for what it thought you said, and get students to experiment with that and understand that context makes a difference with how it understands and interprets what you're saying. We also know that you need to have some unplugged activities, right? Some opportunities for students to learn harder and deeper concepts in a tangible way. So thinking about doing unplugged activities about AI algorithms or how neural networks work, so that students actually get to kinesthetically engage in these or work them out via paper. My favorite is that we really think we need to have students explore case studies of AI-related societal issues from multiple perspectives. So a curriculum that we're developing in Georgia, we have students do this case study in our autonomous robots and self-driving car unit, where they actually get to watch videos of people driving and sleeping Teslas. And these are news article videos where news media videos where you can actually see police officers there, lawyers, people that saw the person sleeping. They never actually have the person sleeping, probably for legal reasons, besides that you're seeing them. And they actually get to explore what are the issues that arise, who's responsible? Is if the car drives, if someone's sleeping, how autonomous is it? Does it really need a human in it? Is the company responsible because they made something that's possible to drive or to hack by, attaching water bottles to it? Or is the driver responsible, and how responsible? And getting them to really explore levels of automation. So we find that these case studies are really nice for helping them kind of jump into the ethical issues, the societal issues, the privacy issues, the responsibility issues of AI. And I think the more that they can do that, the more likely they're able to recognize when these issues arise in their everyday lives. And of course, as Cynthia mentioned, having students actually build their own AI applications. MIT has done an amazing job, as well as other colleagues at other institutions, of building tools that students can actually use real AI APIs and bring their ideas to life with AI. So as we think about what are the fundamental literacies we want students to have, is we really want them to understand how AI works, the limitations of AI, really build a systems level thinking about AI being built up of smaller parts, understanding that AI isn't a monolithic thing. There's not one AI technology, there's many AI technologies that you can put together. Understand the sources of bias, not just in a final system, but all the stages that go along with actually building out that system and using it. And then the societal impacts of AI systems. So that's the big thing that we really think is really, really important for students to know. And I don't know how many more minutes they have. So maybe, do I have about 1 or 2? How am I doing on time? Am I over?
We have some leeway, so you could have another minute
Okay.
or
So I'll jump to, so on our website, we have a resource directory, and we link to the MIT Raise materials, as well as a bunch of materials that have books for children, books for adults, competitions, curriculum materials, demos, professional development, any kind of resource or you think that you might want to use. We have a lot of them documented here, and we try to pull from what people are doing. So that way you have kind of a one-stop shop to go and find tools and resources for you and your students in your districts and communities. the work we've been doing, similar to what Cynthia was mentioning, we thought we were developing national guidelines for how to teach artificial intelligence in the US, but through our work, we've been able to expand globally. And so we find that people are adapting the 5 big ideas or the guidelines and using those to create state and national standards for other countries. And you can see that this is our big idea wheel poster. And you can see it's been translated into over 16 different languages. And it's really, these are really grassroots efforts. People say, I love this work. I'd love to translate your materials. Can we translate? And we say, yes, we don't have translation material, time or money or resources. They're like, we'll do it for you, right? So this is I really think that this is a communal effort of really thinking about how do we get AI into the hands of teachers and students across the globe. We know that to make K-12 AI education a reality, we really need to build teacher capacity. And so that means providing ongoing teacher professional development, as you heard Cynthia talk about that, developing AI curriculum and resources that, meet students at every developmental ability and capability, as well as every grade band, and building a community of teachers to share expertise and experiences and effective practices, because I think we're still learning a lot through all the different NSF funded projects on this, as well as this curriculum being in the classroom about how do we do this well, and exploring cross-curricular connections. So AI and science, AI and health, AI and music, AI and art, really looking at those cross-curricular activities, because for some schools, they're not going to have a dedicated, we're still working on kind of get dedicated computer science teachers, let alone getting a dedicated AI teacher that we need to be thinking about these cross-curricular opportunities. And that's an equity issue to make sure that everybody has access to computer science. And then fostering connections between schools, industries, and communities to really help students and parents understand how is AI affecting us in our local community, and what are the ways that we can embrace it? What are the challenges that we need to be prepared for? So I'll just leave it at this. We've been working with states over the last couple of years to get them to develop state plans for integrating artificial intelligence into their states' plans. And we've had, this was work that we started doing in January of 2021. We had 27 states participate across three U.S. territories, including the U.S. Virgin Islands and Puerto Rico. And we had 15 states complete plans, and then some other states, at least 2 additional states complete plans after the workshops. And we've been keeping in contact with them through quarterly meetings, and really trying to understand what are the challenges to getting artificial intelligence adopted in their state, and what are the best practices that we can learn, so that way we can propagate that through. So the next time I show you that slide like this, we can have all 50 of our states covered. And one of the biggest ways that we've seen this work done is to actually create career and technical education frameworks that allow us to think about how we get students workforce ready for AI. So we've had 5 states doing that. So if you're interested in any of these things, I'm happy to answer questions and provide resources. So I will stop there. Thank you so much for the extra time.
Yeah, thank you so much. Really appreciate your talk today. We're going to transition now to our final speaker before the panel discussion, which is Dr. Ken Holstein. Dr. Holstein is an assistant professor in the Human Computer Interaction Institute at Carnegie Mellon University, where he leads the Co-Augmentation Learning and AI Koala Lab. Their research focuses on supporting effective forms of AI augmented work in real-world contexts, and on scaffolding more responsible AI development practices in industry and the public sector. Throughout their work, they draw on approaches from human-computer interaction, AI, design, psychology, statistics, and the learning sciences. Their work has received awards at ACM Chi, IEEE SATML, AI Ed, and ICLS, and has been covered by outlets such as PBS, Wired, Forbes, the Boston Globe, the Hechinger Report, and Marketplace Tech. And with that, I'll hand it over to you, Ken.
Thank you so much for the introduction. Yeah, so today I'll briefly overview some of our work, and I'll try to sprinkle in these slides links and references where you can learn more. So first, for a bit of background on some of the challenges that we're interested in addressing in my group. Today, AI systems are increasingly used to support human work in deeply social contexts, such as classroom teaching, healthcare, and social work. And AI-based tools are often introduced into these contexts with the hopes of improving efficiency and helping to overcome limitations in human judgment and decision-making. But at the same time, AI-based judgments are themselves imperfect and biased, even if in different ways than humans. And we see growing recognition of this duality in popular discourse. So for every news headline that you see espousing the promise of using data-driven AI models to improve upon flawed human systems, there's typically several others discussing ways AI risks making things even worse. So a long line of literature suggests that in many domains, humans and AI systems have complementary abilities and limitations. And while this gap may narrow over time, many skills we expect will fundamentally defy automation. So to realize the benefits of AI and mitigate its risks moving forward, as well as today, it's critical that we design to take advantage of what humans do best, while also helping humans overcome their own limitations. The design of human-AI partnerships for work has been explored across a range of domains with rather mixed results. So several studies show that when humans and AI systems work together, this can improve decision-making compared with either humans or AI working alone. But in many other cases, AI augmentation actually fails to improve or may even hurt decision-making. So why do some human-AI partnerships succeed while others fail? There are actually quite a number of reasons, too many for me to enumerate in this talk. So in my research group at CMU, the Koala Lab, several of our projects involve going out into workplace contexts that are beginning to experiment with some form of AI augmentation for workers. And we study how these AI tools are designed, how they're integrated into organizations, and how workers actually use them day to day. And as a common theme, we observe too many missed opportunities to meaningfully enhance workers' abilities. So given today's theme, I'll highlight a few reasons for this that I believe can greatly benefit from a learning sciences and education perspective. First, we find that in many high-stakes contexts where AI-based decision support tools are deployed, somewhat surprisingly, there's little, often zero, training offered to workers specifically aimed at helping them learn to use these tools effectively and responsibly. Second, we often see that AI tools fail in practice in large part because their designs are based on an impoverished understanding in the first place of human workers' expertise in the domain. And without this understanding of human workers' strengths and limitations, AI-based tools are often not designed to solve the right problems in the first place. And inaccurate assumptions about human tasks and expertise often then get baked into metrics that are used to evaluate AI systems, which can make it harder for developers to detect these problems proactively before a system is fully built and deployed. So more broadly, many of these issues arise in part because workers and other relevant stakeholders are not adequately involved in designing, testing, and critiquing these systems before they're deployed. And this is often because they are perceived as not having the right literacies to meaningfully participate around AI deployments. So in the rest of this talk, I'll briefly overview some of the work that we're doing to address challenges we see as AI is introduced into a growing range of workplace contexts. And I'm lucky to work with this amazing group of PhD students. Most of the work I'll overview today is led by them. So first, in one strand of our research, we're exploring the design of new kinds of interfaces for worker training and reflection to promote more critical use of AI-based tools in practice. As an example of a specific direction, in many real-world settings we study, frontline workers have access to a lot of decision-relevant information that AI systems cannot access. So to give an example, in K-12 education, teachers have unique knowledge of their students' personalities, emotional states, and home situations that typically AI tools that they use, no matter how much data they have access to, do not. We've found that in practice, oftentimes frontline workers such as teachers will attribute knowledge to AI systems that these systems don't actually have and in fact cannot possibly have. And these misunderstandings bring dangers, such as the risk of over-reliance on AI recommendations. So we've been exploring the effects of trainings and interfaces that can help workers to learn about and reflect upon what are called model unobservables, the information they have access to as humans, but which an AI model does not. And one way we've studied this, at least early on, is through a series of experimental studies in the context of AI-assisted house price prediction, similar to the Zestimate feature on Zillow, if you're familiar. So far, we've found that helping workers better understand how their own perceptual abilities complement those of an AI model can actually enable them to better calibrate their reliance on AI when it's time to make decisions, and reduce their reliance in cases where that makes sense. In another project, we're exploring the design of training interactions for co-creative contexts, such as AI-augmented illustration and manufacturing design. In each of these contexts, we're exploring ways to support designers in learning to work co-creatively and in developing more accurate mental models of co-creative systems' capabilities and limitations in relation to their own abilities as professional designers. So in a second strand of our research, we're developing new methods and tools that can empower non-AI experts to critically engage around the design of AI-based tools that impact their lives. So for example, in a recent project, we developed a comic strip-based method that helps non-AI experts understand and weigh in on otherwise opaque AI system design choices. And we used this method recently with unhoused people and homeless service workers to invite them to scrutinize a real AI system that had been deployed by local government to make decisions about who to prioritize for housing in their city. Overall, we found that when properly empowered to do so, our participants were able to provide specific critical feedback on the AI system's design. So for example, in their own words, participants raised concerns related to the system's overall design objective, choices of outcome proxy variables, and its robustness to dataset shift, among several other concerns. In a related project, we're exploring the design of new tools for user feedback on AI systems' actual behavior. Our goal is to empower end users of algorithmic systems they use day-to-day online to identify harmful algorithmic behaviors and biases based on their lived experience of interacting with AI systems, and to help them push for meaningful improvements, both in everyday use and in workplace contexts. And ultimately, we're interested in fostering a bidirectional learning loop between situated end users on one side and AI developers on the other. So on that note, in a third strand of our research, we focus our attention upstream, viewing AI developers as a critically important group of learners. So for example, we're currently working with AI development teams in both private and public sector contexts to empirically study how they go about brainstorming ideas for new AI systems to build in the first place at the earliest stages of a project. And we're experimenting with the development of new ideation methods and learning resources that can help teams generate innovative ideas that are more likely to produce real value and that are less likely to cause societal harm. So we view this actually as a really important site for AI literacy work, despite these teams having a lot of technical knowledge oftentimes about AI. All right, so I'd like to quickly thank my students and collaborators for this work, again, as well as study participants, research partners, and funders. And thank you for listening.
Thank you so much. And thank you to all of the panelists for their talk. We have some time remaining for some group discussion. If you have any remaining questions, feel free to drop them in the Q&A. Just to start us off, we heard from multiple perspectives on AI education today, including introducing AI in K-12 classrooms, as well as introducing AI in the workplace and thinking about what AI education and sort of mutual learning looks like in that space. I'm curious to hear from the panelists how you think AI literacy needs and AI education initiatives differ across different age groups and audiences.
I guess I can kick that off. So wearing my MIT Dean for Digital Learning hat, I actually oversee open learning, which is MIT's distribution of AI education materials all over the world. So I also have a grant with the Air Force around AI education. So I've looked at kind of these two very different audiences. And I mean, not surprisingly, just kind of like just as a baseline, adult learning often, unless you're going to a community college or a university, you're learning online, and you know what that experience is, right? So it tends to be fairly passive. Maybe you have some group discussions, maybe you work some problem sets. In many cases, you feel very alone. Maybe in other examples, you might have some group engagement, but it's the online learning world writ large in general, I would say, for adult AI education. I think there's been more work in looking at VR, AR, other ways to try to bring what we know, is engaging, team-based, project-based learning, but not only to the online world, but I would say even to adult learners as well. So, in my own kind of research projects, we've been exploring exactly that. If we do constructionist learning paradigms for K-12, do leaders of the Air Force, for instance, like to learn that way, even if they don't have very much background in computer science? And it turns out they do, right? So if you can design the right technologies and interfaces that allow them to engage and build those intuitions through making things, they love it, right? So I think the principles, are very consistent. It's just sort of the reality of what's available now is very kind of lopsided. So I think a lot of opportunity for research and innovation on bringing more of what we know actually works great for kids to the adult learning world, but to do that at scale, right? So anyway, that's how I've been thinking about it.
Yeah, I think so. If you're thinking kind of about workforce, if I'm thinking about university, University of Florida considers themselves the AI university. We're thinking about AI across the curriculum. And so we have hired, I think over 100 AI faculty across every one of our departments and colleges to make sure that we are thinking about how AI affects the curriculum in those areas to better prepare students for the workforce. So we see that, we see a lot of people creating, I think we have like a certificate in almost all of our programs now that offer students at least 9 credits in thinking about what does AI look like in my discipline. And then there's always a capstone project where they actually have to do something in their discipline. So I think helping students see what they're going to be doing in the workforce and helping them see and position their expertise in their disciplines through AI lenses, I think is super helpful, because I think most of us are going to be in what I consider this middle tier of AI enabled workforce. So we're going to be using AI as tools in our everyday work environments. So looking at what does that look like, and how do I have the skills to do that? I think on the K-12 level, I think in elementary school, what we imagine is that students are it's just going to be integrated into what they already do. And that's one of the approaches we took with the guideline development for the K2 and 3-5 guidelines, was really think about, if we only have one teacher, and most of the time they have one, maybe 2 teachers in elementary school, right, that teach all the subjects, how can they integrate AI into the lessons that they're already doing? So it would be a lot of hands-on activities, teacher-led activities to kind of expose students to AI. I think once we get into middle school, there's a ton of tools that we think they can actually start building their own projects and doing some things. And in the curriculum that we've been developing for Georgia and our Artificial Intelligence for Georgia project, it's getting them think about, how does AI affect my community? How is it going to affect my day-to-day life? What does AI look like? And then in high school, there's opportunities for, specific pathways for students to learn how to program, but also learn about artificial intelligence and machine learning and kind of begin building those technical skills. So that's kind of the way I kind of envision kind of how it shifts. Pedagogy I won't even jump into that, because there's a bunch of pedagogical ways that you can do that across all of these spaces.
I can say from my side briefly, and what I'm about to say isn't necessarily limited to age differences. A lot of the context that we work in, For example, where our goal is to support some form of learning quickly to facilitate some form of civic engagement or participation in design, we run under the assumption that we may only have about 5 minutes, maybe in some cases a minute, 30 minutes, somewhere around that time scale to actually engage people. And so that shapes a lot of our design with adults, community members outside of formal learning settings, but in interesting ways where that we take that as a design challenge.
Yeah, absolutely. Thank you. I want to bring up a question from the chat. Since LLMs like ChatGPT and Bard can generate text, this seems like a fundamental change in how students create written expressions of understanding. Is anyone developing any tools or frameworks on how to adjust how we teach and assess writing in K through 12 schools? And I'll kind of broaden that a little bit. So both that question from the audience member, as well as I'm sort of curious about this question of how can we, shift and change AI education to sort of keep up to match the sort of like ever shifting needs by some of these rapidly developing new AI technologies. So I'll leave kind of both of those questions open for the panelists.
So I'll just jump in quickly. So, for instance, through the Day of AI that I mentioned, because it's a short format curriculum, we're actually able to be pretty responsive. So I just mentioned we recently released a chat GPT module just because of all of the discussion that, of course, you can't avoid it, that you hear are taking place in schools, concerns by teachers, parents, students. So, I feel there's a bidirectionality there, right? Chat GPT is, as it is right now, is not well suited to education. It's not designed for that. LLMs could be a technology that could be potentially a transformative technology for education, but that's going to take, I think, a lot of research and development and careful consideration. So just to acknowledge that is a technology that, that could transform current practices in a positive way if done well, right? But a lot of caveats there. The way that we're starting in our work is we're trying to at least have a dialogue, or allow certainly teachers and students to have a dialogue about these technologies. And so the way we're trying to facilitate that, again, we have curriculum where we try to demystify, give them access, but allow students to actually make things with that technology in a variety of ways, get experience and see. It's not just like it does it all. I mean, often you edit, you tweak, you see the limitations. And that provides a substrate in which now the classroom and the teacher can really have a thoughtful discussion of what does this mean for you? What do you think this might mean for the future? What's the context of how this is appropriately used in classrooms or not? So that's the way we're approaching it. And part of what we're hoping through this Day of AI, by getting, knowing which teachers are downloading those curriculum, we actually want to reach out to them and learn from them and have that discussion. So I'd say we're very much in kind of like trying to understand mode. Where we're seeing where the technology is and where it can go, but trying to also meet teachers and students where they are, so we can again engage and best support their understanding and I think discovery as well.
Yeah, I think it's really helpful for students to understand how that technology is working. And so haven't had your resources. I bookmarked it the other day, but I think that's really the big thing is how are these technologies working? How are they trained? Is one of the things that I think is going to be really, really important as we think about helping people have general literacies around what AI, what AI is and the AI that they're engaging with. But what I've seen on the undergraduate level, I'm in a computer science department, is, I see faculty members freak out and go, oh my God, he's going to cheat on these activities, they're going to take our question prompts, put it into Chat GPT or Copilot or whoever, and have it generate code for them. And so on the introductory programming level, where we really do want them to understand the fundamentals of programming, we see faculty kind of I wouldn't say overreacting, but cheating's a problem anyway, right? Around intro programming, because sometimes students just get nervous, right? And so we've had faculty run through every assignment they do through Chat GPT and Copilot and see what it generates, so that they know if you use this technology and they set policies on, we're going to count this as cheating. I teach a software engineering class, and I'll be I haven't taught it in a while, but I'll be teaching in the fall. I'm thinking about that course has always been about how do we prepare students to get internships and work in industry. The way that I'm going to be redesigning the course is I'm going to pull Copilot in and say, hey, let's use that as a tool. You know, you can run your programs through that, but you are going to still need to be able to explain how that code works. You're going to have to be able to fix the breakdowns and understand what are the limitations of this technology. So this idea of having to do reflective practice as they're using these tools to actually design systems, right? And I think it's going to be, I think the answer is how do we use it? It's going to be where are we on the developmental trajectory of a student? I don't think it's appropriate in an intro programming class where we want them to understand and develop the fundamentals. But as soon as we get into kind of practice and application-based classes, hey, let's embrace it because they're probably going to be using these tools in industry. We should make sure that we're preparing them to do so.
I can respond to part of this question, an aspect of this question. So in terms of kind of the pace of change of these technologies and how we keep up in terms of educational interventions, some of our work is very, very grounded and rooted to specific AI technologies, even specific tools in some cases for workplace contexts. But in other cases, we're really focusing on aspects that we think will be fairly invariant over time. So an example for AI developers, one area that I'm very interested in, we have a project focusing on trying to help support AI development teams. And by this, I don't just mean ML developers, I mean also designers and various roles that you find in industry. To learn to collaborate cross-functionally and have discussions cross-functionally more effectively. And so that's an example of something that I would expect to be fairly robust to specific changes in technologies.
Yeah, well, thank you so much to our panelists. I wish we had more time to go on and continue discussion today, but we should probably wrap up soon. I did see one question from a graduate student in the Q&A asking how to get involved with some of these AI education initiatives. And I thought maybe that would be a good question to close with. If any of you have any suggestions for individuals who may be looking to get involved in research in this area. Yeah, I'll leave that open as our last very quick question.
I would say I can speak on kind of if you're interested in being in classrooms and working with people around policy and trying to get curriculum and stuff written. I'm happy to connect you to the different state groups that we have working on this. So if there's a group in your state, happy to connect you there. If you feel like, even if you're not a graduate student and you feel like you want to get involved in this work, help you get some tools to get a group of people thinking about this in your state and moving this forward. So I'm happy to make some of those connections. And then there was something else I wanted to say. But maybe that we also have the AI for K-12 mailing list that I encourage you to get on. There's lots of great discussions and often opportunities for you to collaborate with people and hear about some of the new stuff that's going on. So I'll just throw in the website aifork12.org. There's a link on there for joining the mailing list. So doing one or both of those things, I think would kind of start getting you engaged with that community a little bit more.
Great. Well, thank you so much to all of our panelists and for everyone in the audience for attending and contributing your thoughts today. And I hope everyone has a wonderful weekend.